Hello. In this video, we're going to take an introductory look into functions, and in particular how relations and functions seem very similar, but they're in fact two different things. A relation is a set of ordered pairs or independent values paired with dependent values. A function, however, is a relation where each independent value corresponds to only one dependent value. So let's take, for example, if I have numbers 1, 2, 3, 4, and those values correspond to the numbers 9, 4, and 3. So that means that 1 corresponds to both 9 and 4, 2 to 3, 3 to 3, and then say 4 to 4. So we have these kind of ordered pairs. So essentially I have 1 and 9, 1 and 4, 2 and 3, 3 and 3, and last one, 4 and 4. Oh, change that, 4 and 4. Because in this case, 1 corresponds to both 9 and 4, this is only a relation, but not a function. So a function only has kind of one in this case when we map it, only has one dependent value for every independent value. We can have multiple dependent values chosen for different independent values, but each independent value only has, say, 1. So let's take a look at another set of ordered pairs that I've pre-made. So in this case, every one of my kind of inputs has a corresponding output. Inputs, outputs. So for every one I put in, I get 3, 2, 5, 3, 6, 4, 8. Because each one of these here only has one kind of dependent value, this is defined as a function. So my ordered pairs are 1, 3, 2, 5, 3, 6, and 4, 8. So they're all kind of corresponding together. Now, because this is a function, I can actually define it having a domain. And the domain is essentially all of its kind of independent values. So the domain for this function is 1, 2, 3, and 4. The range are all the dependent values. 3, 5, 6, and 8. Oh, square that bracket. So basically these are all the independent values, and these are all the dependent values. So we have like this relation which only has like kind of inputs and outputs, or just kind of ordered pairs. A function has an input that has only one defined output, and that's the thing. So for every one number I put in, I get like kind of an output. So if you think about it like in terms of the mapping that we were doing before, if I have, say, the numbers 8, 9, 12, and 14, and so these are my kind of inputs, and I have the numbers 20, 21, and 23, and I map them. So every time I put in 8, I get the outputs of 20. Every time I put in 9, I get the output of 21. Every time I put in 12, I get 23, and every time I put in 14, I get 23. This is still a function because each one of these inputs only has one output. It doesn't matter the output, there's two values for 23. So 23, I get 23 if I put in 12, or I get 23 if I put in 14. That doesn't really matter in terms of functions, as long as one input gives me one output. So in this case, this is very much a function. And it also would have a domain from 8, 9, 12, and 14 in a range of 20, 21, and 23. So domain is all these independent values, and range is all these dependent values. Now, another way to tell if we have a function or not is called the vertical line test. So if I have any sort of graph like this, so I have this kind of parabola right here. So to tell whether or not it's a function, all I have to do is draw kind of a straight line, as best I can, kind of through the graph. If the straight line only hits it at one point, then it's a function. If I draw a straight line and I hit the graph at 2 points, say like right here, right here, then it's not a function. This is still saying the same thing as I was saying before. For here, for a value of 1, I get a value of 4 and I get a value of negative 4. So 1 corresponds to both 4 and it corresponds to negative 4. That's not a function. So even though this is kind of very similar to each other, if I draw a vertical line, the vertical line test, if I only hit it once, function. If I hit it more than once, then it's not a function. And that's kind of a key thing to remember. With all these kind of functions or non-functions, these functions and relations and how they correspond to each other, vertical line test is a very visual way to kind of see whether or not I'm dealing with a function or not. Now, the other thing we need to get into is kind of this. Oh, here's another examples of functions. Cross the line, right here. Hey, that's a function. The circle, even though I have a formula for a circle, if I draw a line on the graph, a vertical line, well, it hits it at 2 points. Not a function. So linear kind of graph, only 1 point. Hey, function. Circle, not a function. Things can have formulas that are very defined, but they don't necessarily mean that they are functions. Now, the last thing I want to tackle in this video is function notation. And this is a bit mathy, but it's essentially notation that represents the value of a dependent variable, such as f of x or f at x, for any given value of x, the independent variable. So this is taking a look at our kind of input or output kind of idea. What we have is an input that we're going to call, I'm going to call x. Then we have a set of instructions. So this is kind of f, the function, whatever it is, f at whatever. And then we have the output. So whatever I get, kind of f of x. So here we have kind of a linear equation. So y is equal to 2x minus 2. I turn this into kind of function notation by essentially replacing the y with f of x. So this is telling me the function of x is equal to 2x minus 2. So here, if I'm going to input something, so let's say I want to input not x, but I want to input, let's say, 2. So this is then going to go through kind of the instructions. So in this case, the instructions are multiply x by 2, so 2 minus, and then subtract 2. And then it's going to give me an output. Well, 2 times 2 is 4, minus 2 gives me 2. So this is my input, this is my instructions, and this is my output. So let's take a look for it if I was going to input something else. Let's say I input, let's say, negative 1. So I'm going to input negative 1. So the instructions are multiply it by 2 and then subtract 2. So my output is going to be 2 times negative 1 minus 2. It's going to be negative 4. So f of x is what I get out of this. These are my instructions kind of right here. And x is essentially my independent variable that I'm putting into it. Now, let's take a look at maybe another question. So I'm going to come up with two different functions. So my first function is going to be f of x is equal to, I don't know, let's make it a quadratic. Let's make it 2x squared minus x. Simple. And I'm going to have g of x, and that's going to be equal to 1 minus x, some simple linear equation. And I want to know if this statement is true. I want to know if f at 3 is greater than g at 3. So f of x has a set of instructions, g of x has a set of instructions, but I'm putting in the same inputs for each one of these functions. So f of 3 is going to be equal to 2 times 3 squared minus 3. And so that's going to be 9, 18 minus 3 is 15. Now g of x, or g of 3, is equal to 1 minus 3, which equals to negative 2. So 15 being greater than negative 2 makes this a true statement. So that's great. So the x is something that we can change as a variable. It's something we change as like the input. And we use like relations, and we see if relations are functions. We can even see if graphs are functions by the vertical line test. But the key things to put it in to make sure we get straight here is functions only have one kind of output for every single input. And we can determine these through the vertical line test, amongst other things. Also, now we're changing the way we think about things in notation. Instead of y equals mx plus b, we're now using f of x or g of x as our function notation.